Hello, everyone. Welcome back to the channel. Today, we're going to be doing a Sudoku I made. So this is on the website sudoku.coach.com. And it's a website where there's a whole campaign of all the techniques you could use to solve Sudokus, as well as there's a bunch of user-published Sudokus that you could solve. So this is one that I made. Um, it has some variations on the standard Sudoku rules. So the regular rules still apply. You know, there must be exactly one number, 1 through 9, in every row, column, and box. But there's also a couple new rules that I really think spice this puzzle up. So one of those rules is called entropy. And basically what that means is within every 2 by 2 area in the entire grid, there must be a low number, 1, 2, 3, a medium number, 4, 5, 6, and a high number, 7, 8, 9. So just to kind of demonstrate that, let's say in this little 2 by 2 area, we had one number was 8, and another number was 1, and the third number was 2. Right? So we would have two low numbers and a high number, which means the remaining number would have to be a medium number, right? Either 4, 5, or 6. Um, it couldn't be 6 in this case because, 6 is already in the same row, so it would have to be 4 or 5. And this doesn't have to be self-contained in a single box. It could be like between these boxes here as well. So if we had, 4 here, 5 here, then we would have to have a low number and a high number in these two cells, right? So the only situation where this doesn't tell you information is if, let's say we have a low number, a high number, and a medium number, right? Then this could be anything. It could be any of the other numbers because we already satisfied the condition of having one low number, one high number, and one medium number. So that's the entropy rule. The other rule that kind of spices up this puzzle is called the region sum line. So that's this really long blue line that goes throughout the entire puzzle. I think it kind of looks like a road. So the name of this puzzle is called the long road ahead. Um, Basically, what the region sum line says is that um, for any continuous blue line, right, um, all of the cells it passes through in a certain box have to sum up to a single number. So for example, let's say in this box, we had 2, 3, and 5, right? That would sum up to 10. That means in this box, the sum would also have to be 10. So maybe we could get there by having 1 and then 6 and then 3, right? For example. The only thing with the region sum lines that could be a little bit confusing is that two different lines are completely independent of each other. So let's say the sum in each box on this really long line has to be 10. That does not apply for these other lines that are separate. For example, like this line, or hold on, this line, or this line, or this line, right? So we have, in this puzzle at least, we have this one really long main road, and then we have 4 side roads that give us independent information, right? Anyway, I will put a link to this in the description if y'all want to go ahead and try to give it a solve, but for the rest of the video, I'm just going to go through and solve it. So, spoiler alert, I'm going to go ahead and start doing that right now. Okay, so let's go ahead and start off with this box in the top left, right? Because this gives us a lot of information. So we see that this first segment of the blue line has 5 different cells in it. And we see this second segment of the blue line, and it's the same line if you follow it. Go all the way around. It is one single line. So this second segment of the line only has 2 cells in it. So essentially, what that means is that we have 5 cells that sum up to the same thing as these 2 cells, right? So we have to have high numbers in these 2 and low numbers in this one, right? So what is the lowest sum we can come up with from these 5 cells? That would be 1, 2, 3, 4, 5, right? 1 plus 2 plus 3 plus 4 plus 5, that is 15, right? The only way, and the highest number we can get from these 2 cells would be 8 and 9, that would be 17. So we know that this region sum line has to equal either 15, 16, or 17, just from this knowledge that we see in the first box on the top left, right? So We could also conclude that it's not 16, because if it was 16, then this would have to be an 8 and an 8 in the same box. That's not possible, according to just the standard rules of Sudoku. So it either has to be, um, the sum has to be 15 or 17, and this number here has to be either 7 or 9, right? Okay, so let's go ahead and use the rules of entropy now. So we know in this 2 by 2 region, there has to be a low number. We already got that. A high number, which we already have 8, but also the 7 and 9 are both high numbers. So what we're missing is we have to have a medium number, 4, 5, or 6 in this remaining cell. But 5 and 6 are already not options because they're in the same column. So that leaves us, the only number that can be here is 4. Okay, so that actually gives us a lot of new information about the sum line here, because now 4 can't be in the sum of 5 cells. So now the new lowest number we can get to would be 1, 2, 3, 5, 6, and that sums up to 17, right? And that is the highest possible number we could have because 8 and 9 also sums up to 17. So from that, we can conclude that this number right here must be 9, and these numbers right here must be 2, 3, 5, and 6. Because if they were any higher, then you couldn't get a sum of these 2 cells equaling the sum of these 5 cells. Okay, so let's go ahead and just eliminate this 2 here because it's in the same row. But let's go over to this cell now. We know that there's 1, 2, 3, 4, 5, 6, 8, and 9. What are we missing? That's a 7. So we know 7 is the remaining cell there. And then let's go ahead and look at this little area. We have a high number, and a medium number. We know this must be a low number, so it can't be 5 or 6. And that is about all the information we can get from that cell. So let's move on to this next box on the left. We know these 3 lines, because part of the same overall region sum line, these 3 must sum up to 17, right? Okay, so we could also get a lot of information from this little side road right here. It has 8 on this side, and it has 5 on this side. So we know these 3 cells must sum up to 8, right? The only way we could do that is with 5, 1, and 2. So we know there must be a 1 and a 2 there. And now we could use the rules of entropy. Here, we have a low number, and a high number. So this must be a medium number, 4, 5, 6. It can't be 5, because that's already in the box, so it must be 4 or 6, right? So if this is either 4 or 6, and these 3 cells have to sum to 17, then these 2 cells have to either sum to 11 or 13, right? Let's say it's 11. Well, the only way we can get to 11 is 5 and 6. That's not possible because there's already a 5 right here. We could do 8 and 3. That's not possible because there's an 8 right here. We could do 9 and 2. That's also not possible because there's a 9 here. So the only way we can get to 11 is with 7 and 4. Let's take the case of 13 now. We could either do 5 and 8. That's not possible because there's a 5 here and an 8 here. We could do 7 and 6, which is possible, or we could do 9 and 4, which is not possible because there is a 9 here. So you'll notice that in the only options for these 2 cells are 4, 7, and 6. So we're going to go and fill those in. And this specific cell can't be 4 because it's blocked by this other 4. Okay, so now let's go through all the numbers in this box. We have 1, 2, 4, 5, 6, 7, 9. We're missing a 3 and an 8. Now we can go and use the rules of entropy. So we know we have a high number here. We have a medium number here. This could be either a medium or a high number. The thing is, the only way we could have a low number in this box is if there's a 3 right there. So that's going to be 3. Then this must be 8. Let's also use the rules of entropy here. We know we have low numbers here and here, a medium number there. This one must be a high number, therefore that's got to be 7. And that is all the information we can get about this box right now. So let's go and move down to the next box. So we only have 2 cells on the main road in this box, and we know this main road must sum up to 17. The only way we could do that was with an 8 and a 9. Well, the only spots for those are 9 here and 8 here, so that's pretty easy. We could also use the rules of entropy here. We have a medium number, and a high number. This must be a low number, 1, 2, or 3. It can't be 1 or 2 because those must be in these 2 cells respectively. So this has to be a 3. And then the rules of entropy here, we have a high number, and a low number. This must be a medium number. It can't be a 4 or a 6 because those are in those 2 cells respectively. So this has got to be a 5. Okay, so this leaves, the only numbers left are 1, 2, I'm actually going to switch to here, 1, 2, 4, and 7. So let's go ahead and get rid of 7 here. Let's go ahead and get rid of 1 here. And we know 4 can't be here either because 4 and 6 have to be in these 2 cells. So we know this number right here is 2. Let's use the rules of entropy right here as well. So we have a high number, and a medium number. Therefore, this has got to be our low number. The only low number it can be is 1. So that is 1. So that is all the information we can get from this box right now. But as you'll notice up here, all of the other candidates for this cell got eliminated, right? So the only possible thing that can be in this cell is R3. Okay, let's go ahead and move on to this next box right here. So you'll notice there are 5 cells on the main road in this box, just like how it was in the first box in the top left. It can't be 6, but there's a lot of other combinations which we can get to go to 17. So let's actually go over to this side road real quick to see if there's any information we can get from that. So first, let's use the rules of entropy here. We have a low number, 2 medium numbers. This must be a high number. It can't be 8, so it has to be 7 or 9. Now let's think about if we have 4 plus 7, then that gets us to 11. If we have 4 plus 9, that gets us to 13, right? The maximum that we can get on this side would be 6 plus 8, right? Because we can't do 6 plus 9. This is already blocked by the 9. So the maximum we can get would be 14. So if we had 4 plus 9, this would be 13. We would have to have 1 more. It can't be 1. The lowest number we could put here would be 2. So the lowest sum we could have, if this was 9, would be 15. That's too high, so that's impossible to do. Therefore, 9 is not an option. This means 7 must be our option here. So we have 4 plus 7, that's 11. We could have 2, 3. That would get us to 13 and 14, respectively. Those are the only 2 numbers that it could be. And in order to get to 13 and 14 here, we would have to have 7 or 8. So now we could use the rules of entropy again. It's a very powerful rule. We have a high number here with 7. We have a high number here. We have a low number here. This must be a medium number. It can't be 4, can't be 6. It's got to be 5. Okay. So now we know that on this main road, we can't have a 5 or a 6. Really is limiting our options, right? So how else would we get to 17? What we could do is 1, 2, 3, 4. That gets us to 10. And then the next number we would have to do is 7, right? So that is the only remaining way to get to 17. So we can go ahead and fill in that the only remaining numbers here are 1, 2, 3, 4, and 7. And if 1, 2, 3, 4, and 7 have to be on this main road, that means 7 cannot be here. That must be an 8. 6 and 8 is 14. The only way to get to 14 here is 4 plus 7 plus 3, so that must be a 3. Let's go and use the rules of entropy here. We have a medium, a high. This must be a low number, therefore it can't be a 4 or 7. These cannot be 2 because there's already a 2 in this row. This can't be a 1 because there's already a 1 right here. And this can't be a 3. I believe that's pretty much all that we could eliminate from this line right here. But you'll notice we have one cell that's the odd one out. Well, what are we missing? We got 1, 2, 3, 4, 5, 6, 8, oh, and 7. Therefore, the only one remaining is 9, which must go here. Okay. So the next thing we could do, right, let's take a look at some of our numbers here. 1 has to go in these 4. 2 has to go in these 4. 3, we don't have a ton of information about. We have 6 possible candidate cells. 4, we also have basically no information about. 5, we have a little bit. 6 is really the interesting one. So 6 can't go in this row or in this row. So it must be on the main road in this section. So 6 has got to be right there. So that means, again, each of these sections has to sum to 17. The remaining 2 cells, we don't know if the 6 is in here, here, or here, but we know the remaining 2 cells must sum up to 11, right? So the only way we could do that is with 9 and 2, not an option because 9's already in this row. 8 and 3, also not an option. 5 and 6, not an option either. So the only way we could do it is with 4 and 7. So 4 and 7 appear on the line again. Seems like it's been kind of a common theme with these 3 cells. But 4 and 7 have to be here. And if 4 and 7 are on this row, then that means they cannot be right here, which means that's a 2. So we know the remaining 2 must be in one of these 2 cells. And we could also say it must be in one of these 2 cells. And it must be in one of these 2 cells. So I believe that's all of the remaining slots for 2 on the entire grid. So every instance of a 2 is bilocal, which means it can only be in 2 possible candidate cells now. So that gives us a lot of information. Actually, there is this cell we still have to address. So we're not out of the woods yet. Let's go ahead and use the rules of entropy here, just because I noticed that there is this box which has 3 things filled in. We have a low number, and a high number. This must be a medium number. Can't be 5, can't be 4. This has got to be 6. And since we filled in every other cell in this box, the remaining ones are 1, we already got 2, and then 3, 4, 5, 6, 7, 8, the remaining, and then 9, right? And you'll notice 1 plus 2 plus 5 plus 9, what do you know? It equals 17. So the whole sum of 17 is still working, which is good. It means we haven't messed up anything yet. But by filling in 6 here, we notice 4 is the only option left here, and that 6 is the only option left here. So that gives us some good information. Let's see if there's any other numbers we could eliminate right here. Isn't blocked by any 1s. We already got those 2s. 5s, there's no conflicts, and 9s, there's no conflicts. Okay. And I don't believe that there are any ways we could use entropy here, just because all of these cells we have, they're already pretty entropic. They have a mixture of medium and low, so we don't have any information about that right this instant. So let's go and move on to this line right here. As you'll notice with this row, we have everything filled in except 2 numbers. Those 2 numbers are 2 and 9. Therefore, this sum is 11, which means we must have a 6 in order to bring it to 17. So we must have a 6 right there. Let's also go and look at where our 8 could be. We know it can't be here because this must equal to a 9. We know it can't be here because there's already an 8 in this row. Has to be here or here. And this is the perfect opportunity to look at our next side road right here. This is our final side road actually. Starts with a 1, ends with a 2. And it's completely vertical, so that helps because the regular column rules still apply. Where only one number where a number can only appear once in a column. So let's say hypothetically, if the 8 is there, then we would have 1, 8, so that would be 9, and then the lowest number we could put here would be 3, because we can't put 1 or 2, they're already in the column. 1 plus 8 plus 3 is 12. Well, on the other side, the only way we can get 12 is 2 plus 10, and 10 is not a number in Sudoku. So it's impossible for 8 to be right there, which means we just solved our 8. It's got to be there. We also know that in this cell specifically, we can't have a 3, a 2, a 4, a 6, a 7, an 8. A 9 also doesn't work by a similar logic is why 8 doesn't work, right? If we were to have a 9 here, then there's no way 2 could, reach a sum that's as high, right? So 9 can't be here either, which means the only possible candidate left for the cell is a 5. So now we have 1 plus 5, 6. The lowest number we could have here would be 3, which means that the lowest number we could have in this cell, 1 plus 5 plus 3 is 9. The lowest number we could have in this cell is 7. That's not a possibility because 7's already in this row. Therefore, this has got to be either 8 or 9. And if this is 8 or 9, that means the sum is either 10 or 11. The only way we can get 10 or 11 here is if we have 5 or 6. But 5's already in the box and the row, so that's not an option. Therefore, 6 is our, oh, oops. Must have made a mistake here. Oh, sorry about that. The only options are 4 and 5. 5 is not an option, therefore 4 is the only option. Okay, so what do we have remaining in this box, right? We have 1, 2, we don't have a 3 yet, so let's go ahead and put 3. 4, 5, 6, don't have a 7 yet. That's going to be our other member of the box. So that, I believe, is all the information that we can get from this box right now. So let's go ahead and this is where the puzzle gets a little bit more complicated. So we got to use a lot of chains of logic here that we didn't have to use in the previous boxes that we went over. So actually, first of all, one easy thing we could do, if we know the sum here is 10, we know this is an 8, right? So that is a pretty easy thing we could do. We also can say that this is an 8 right here, because by the standard rules of Sudoku, that's the only possible option. And then we can say this is an 8 right there. Right? So we're going to kind of skip over this line for now. We'll come back to it. But this final segment of the line, right, we know it has to equal 17, right? We already have an 8, so these three must sum up to 9. So how can they sum up to 9? Well, what we could do is 1, 3, 5, or 2, 3, 4, or 6, 2, 1, right? Because we can't do 7, 1, 1, because that would mean 1 would appear twice. So let's go ahead and see if we could do 6, 2, 1. Well, the only spot for 6 would be here, but that's also the only spot for 2. So we can't have 6 and 2 in the same cell. So 6, 2, 1 is not an option. Therefore, we know it's either 1, 3, 5 or 2, 3, 4, which means 3 has to appear in this final line segment. It can't appear in the middle, so it's got to be there or there. But as far as the 4 and the 5, those have more remaining options, and we don't know if it's a 4 or a 5 in this segment yet. So we'll just fill those in as potential candidates. There's a 4 here, here. Actually, it can't be there. It could be there or there. Again, there's a possibility of 4 is not on this line segment. As far as the 5, there's really a lot of places a 5 can go there. It can go any of those spots. Let's go ahead and take a look at our 6s again. By the previous logic, we know 6 cannot be here. Therefore, we know a 6 must be either in this cell or this cell, right? But that means that we have a in this 2 by 2 area, we have a high number and two medium numbers, which means the remaining numbers here must be low numbers. Um, so 3 can't be here or here, right? Because it must be on this line. So this can either be a 1 or a 2, right? Let's just go ahead and go through each number, see if we can identify any patterns and fill in the remaining cells. So let's look at this cell. We know 1 must be there. That actually gives us some good information because we know we have a high number and there must be at least two low numbers. 1 and 2 have to appear in this area, which means the remaining number in this little area has to be either a 4, 5, or 6. We know it can't be 6 because the 6 is already up here, and we know it can't be 4 because a 4 already must be on the line up here. So 5 has to be in this 2 by 2 area, can't be in the top, so it has to be right there, which means we have a locked pair of 1 and 2. So anything that this 1 and 2 sees cannot be a 1 and 2, which means that can't be a 1, that must be a 3. And look at that, that actually gives us a lot of new information. We agreed earlier that the 3 must be on this segment. It can't be in this place or this place, so it has to be in this cell. So we have 3 and 8, that's 11. These two numbers have to sum to 6, right? So the only way we could do that is with a 4 and a 2, or a 5 and a 1. We can't be 1, so it has to be a 4 and a 2 there. And that is what that segment equals, which leaves us with a locked pair right here. We know this must be 1 and 6, so 1 and 6 cannot appear in these three areas. So let's look at the remaining candidates for the cell. We have 1, 2, 3, 4. 5 can technically be in any of these three right now. 6, 7, which can't be in these two or these two because they're locked, so we know 7 must be here. 8 and 9. So I don't believe, yeah, I believe that means we have a locked pair right here, 5 and 9, which means neither of these two can be 5 and 9. So 9 must be in one of those two cells. So we don't have a lot of information right now on these two cells. But one thing that we do have, looks like through process of elimination, 1 is the only option in this cell. So that gives us some good information. This leaves 4 and 7 as locked candidates. Let's go back to this box right here. I know we're jumping all over the place, but you kind of have to at this point in the game. We have 1, 2, 4, 5, 6, 7, 8, which means 3 and 9 are the only options here. But 3 and 9 are already here, so this must be 9 and 3 in this order. And now we have, in this column, we have 1, 2, 3, 4, 5. We don't have 6 or 7, so those are our candidates. We do have 8 and 9, though. Okay, so one thing we can find out is that 2, the only place that 2 can go in this box is right here in the bottom left corner, so we're going to put a 2 there. So since we're kind of out of options on most of these solve techniques that we've been using so far, let's just go ahead and fill in all the remaining cell candidates. There aren't too many, so it shouldn't take too long. So here are all the filled in cell candidates, since we've reached a little bit of an impasse. Oh, you know what we could do? We could use entropy right here. We have medium, medium, high. This has got to be a low number. That means that's a 3, that's a 7. That means we only have one remaining 3, which is right there. We got a 4 right there. Looks like we can use entropy again here. Low, medium, medium. It's got to be a high number. 9, 2. Looks like 9 is the only spot this can go here, which means we have 1. Let's see, 3 plus 9, 12, plus 1. That must be a 4. That must be a 5. And look at that. Looks like it's all falling into place like dominoes now. So maybe I spoke too soon. It looks like we have one more solve we have to go through in order to get this to work. So what are we going to do for that one? Well, this is actually, I think we can do it right here because we got a medium, a high number. This must be a low number. And then 5. And hopefully that should give us all of the remaining information we need to solve the puzzle. We could use a wet trick, entropy trick one more time here. Low, low, medium. This has got to be a high number. Um, Low, high, medium doesn't tell us anything. Low, high, medium doesn't tell. Oh, here it is. Low, low, medium. This has got to be high. And there we go. So it took a while to go through all that, even though I did make this puzzle. Still easy to forget a lot of these things. But yeah, that is the long road ahead. Let me know if you like this video. I will leave a link to the puzzle in the description again if you want to try your hand at it. And let me know if you want to see more puzzles from me. Thanks so much for watching.